Then now coming to the next definition, that is the empty set, or in other words null set, or in other words it can also be called as the void set. An empty set, or in other words the null set, or it can also be called as the void set. A set consisting no elements in it will be called as an empty set. So here a set containing or consisting no elements in it is said to be an empty set. Or null set, or in other words the void set. So here the symbolic representation of this null set or the empty set, or in other words void set, is 5. The symbolic representation, or in other words, so here empty set can be denoted by means of the symbol called the phi. The symbolic representation of a null set is phi. So this is the notation of phi. So for instance, let us write, or let us assume the set as A, which is an empty. So for instance sake, set A is an empty set. So here to denote symbolically, since set is denoted by means of the letter called, the capital letter called A, so we can write A equals to, so here brackets begin and ends, but it doesn't consist any sort of elements. So there is no element in this particular set A, or in other words it can also be represented by means of the symbol called phi. Then later let's go for the next definition, that is non-empty set. So here non-empty set mean a set consisting at least one element in it will be called as a non-empty. So here a set containing or consisting at least one element in that particular set or in it is said to be, or is called, is said to be a non-empty set. So whereas here it is not equal to the phi, so here we can guess it as, so here for instance like I say, I will be taking one example. For instance, here the illustration is of set B is a non-empty set. So here we can write it as, so here B is set B denoted by, set is denoted by means of the letter called B. B is non-empty, so it is equals to phi. If I write equals to phi, it will be called as an empty. So here when we cancel up, so here B is not equal to phi, that is empty, then it will be called as a non-empty set. B not equal to phi. Then our next definition is of singleton set. Here the singleton indicates the single element, say here a set consisting only exactly one element in it. So whereas in the previous case non-empty mean it may have one and more than one also, but whereas singleton consists of what I say here only one and only one element in it. Singleton set. So the definition of this is of a set consisting exactly one element in it will be called as an singleton set. So here a set containing or consisting exactly one element in it or in that particular set is said to be a singleton set. Then let us perform one example. So here, for instance sake, so I am going to consider one example, that is set C be a singleton set. So here sets denoted by means of C is a singleton set. So here we have to represent, we have to take one element. So here I am going to considering an element that is 2, which is belonging. So here this indicates belonging. So here the symbol indicates belongs to. So now 2 belongs to the set called C. Now we can write it as set C is denoted by means, set is denoted by means of the letter called C, then set consisting the elements. So here since the singleton consists of particularly exactly one and only one element, whereas here we assume the element present in the particular set C as 2. So here 2 is only the element, so which is in set C. So it will come under the example of singleton set. Then our next one is of finite set. Finite indicates exact. So a set which is an empty or containing finite number of, which is a non-empty and consisting the finite number of elements. So here a set which is non-empty having finite number of elements in it is called the finite set. A set which is non-empty or a non-empty set consisting, or in other words it can also be written as a non-empty set consisting at least one element in it, at least finite number of elements. So here non-empty set consisting finite number of elements in it is called the finite set. A set which is non-empty containing finite number, a definite number of finite, in other words called as the definite number. So here definite number of elements in it is said to be a finite set. So here a set must consist finite number of elements, either 3 or 4. So exact number of or a definite number of elements in it, then only it is said to be called as a finite set. So here example, or for instance sake, let us perform one illustration, that is so here a set of all trains in the world. So it will come under the finite number or the finite sets. Here the number of trains in this particular world are of definite in figure. So we can write it as either 5 lakhs or 4 lakhs or whatever it means. So it has the definite figure. So here when it has the definite figure, then it will be called as the finite set, I say. Then now infinite set. So infinite set mean a set which is not a set which has a set which is not a finite, which has not a finite number of elements in it is said to be called as the infinite set. or in other words, a set which is not a finite one, which doesn't have any sort of definite figure in it. So here, which is not a finite, is said to be an infinite set. Or in other words, it has infinite number of elements in it. So here set consisting the infinite number of elements in it is said to be called as infinite set, which has definite number of elements in it will be called as a finite set. So here trains are definite in figure, so it will be come under the definition of the finite set. Or in other words, a set consisting the definite number of elements, a fixed number of elements will be called as a finite set. Or in other words, infinite set. A set consisting the infinite number of elements present in it is called the infinite set. So here let us perform one example. So for instance sake, a set of all points on a line or on a straight line, it will come under the infinite set. Since this is a line, there is no endpoints on both sides of this line, so it can be extended on both sides indefinitely. So here number of points upon this line are of infinite in number, because it can be extended on either side indefinitely. Therefore the number of points upon it that means the set of all the points which are lying on this line are of infinite in number. Therefore it will come under the infinite set. So line represented by means of AB. So in this manner I say finite set, the set consisting the fixed number of elements in it will be called as a finite set, and the set consisting the infinite number of elements in it will be called as an infinite set.